Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 1 for February-March 2025, and this is paper 1-2. Question 1. A curve has the equation y is equal to 5 plus 3x minus 2x squared, and a straight line has the equation y is equal to kx plus 13, where k is a constant. Find a set of values of k for which the curve and the line do not meet. Now, I will first assume that they meet, and then I get a quadratic equation for the solution of these two, and we are supposed to solve that quadratic equation. But then for no intersection, it means that that quadratic equation cannot be solved. That means actually the discriminant is less than 0. Okay, so I can begin by saying for intersection, then kx plus 13, this y here is substituted with the whole of this, is equal to 5 plus 3x minus 2x squared. Then I bring everything this side. So when I take the 2x this side, 2x squared, it is going to be a positive. And then this one here, we shall have that kx, then minus the 3x, then we shall have the 13, then subtract 5, then simplified to 2x squared, then plus k minus 3. When I factorize out the x, then plus this will be 8. Then we can say for no intersection, b squared minus 4ac is less than 0. That is the discriminant. Remember, you're going to solve the quadratic equation using this bulldozer, minus p plus or minus root of b squared minus 4ac out of 2a. You can solve this equation if, let's say this one is 0. That means this whole thing disappears. You will get one answer, that is a repeated root, minus b over 2a. And then if this one inside here is positive, that means you are in position to get the solution, and you will get two roots. Okay, you will get the plus, and then you also use the minus. But when this one becomes a negative, then that means you will not get the square root of that, you see. So that is why we are taking the discriminant to be less than 0. So our b is k minus 3 squared, then minus 4, a is 2, and then this is 8, now less than 0. This is k minus 3 squared, and this is 64, less than 0. I'm not going to waste time by opening the brackets here because you have to get a quadratic from this. But this is a difference of 2 squares, 8 squared. And for the difference of 2 squares, remember if you have a minus b, a squared minus b squared is equal to a plus b, and then a minus b. So this is the same thing I'm going to use. My a is k minus 3. So I will add the 8, and then k minus 3, then minus 8, less than 0. So this one will be minus 3 plus 8. That one will give us plus 5. And then this one is minus 11. Then when I equate this one to 0, I will get a negative 5. When I get this one to 0, I get 11. So these are my boundary lines, or what we call the critical points. You don't do this. Don't say k plus 5 is less than 0. K minus 11 is less than 0. This is very wrong. This is not how we solve quadratic inequalities. Okay, so having gotten these two answers here, negative 5 and negative 11, I can do a small sketch here. This one here. This is a U-shaped curve because the coefficient of k here comes out to be a positive. K times k, you're going to get k squared. and for any coefficient of k squared here being positive, that will be a U-shaped curve. If it is negative, that will be an N-shaped curve. Okay, now I'll put my values here. The -5 will be here, and then the 11 will be here. Now, this part that is above the k-axis, it is positive. Okay, even this one is positive. So for any values that are going this way, the corresponding k value here will be positive. It will be above the k-axis. Okay, so and then this one is minus. It is below the k-axis. Now we are supposed to pick this one less than 0, which is the negative, so which has to be this region here. Okay, this region here. Now we conclude by saying -5 less than k less than 11. That is where k ranges. So when they say a set of values, then it means an inequality. So that is the set of values.